Good evening to all. Okay, so this is Gopalakrishnan from Chola Academy. Okay, today we are going to discuss about an equation which is very important to deal the projectile motion. Okay, so let's see what is projectile motion. Okay, so see this, a small graph is given with the x and y axis. So when an object travels in the plane like this, like a parabolic path. So this parabolic path can be set as projectile motion. Okay. So here you can see so many parameters like velocity in x-axis, velocity in y-axis, and the resultant velocity in other resultant velocity v naught. Okay. So this diagram shows when your object is thrown in a space at an angle theta naught, where this object will go and fall. So how much distance from the shooting point to the falling point, the distance, this is called r. So this r value can be calculated using a small equation. So the namely r equal to v naught square sine 2 theta naught divided by g. Here g stands for gravitational the acceleration due to gravitation, and v naught is the initial velocity and theta naught is the angle. This is nothing but projectile angle. Okay. So I have one question. I am not changing the force, the velocity which we are going to at initially. So I don't change the velocity. If I change the angle which and the theta naught, if I change the angle theta naught, what will happen to my range? What will happen to my range? Before that, I want to know at which angle the projectile object can travel the maximum range. So to identify that, I can make this the possibility of the at which condition this equation attain the maximum value. Okay. For example, v naught square is a constant. I am going to give g also is a constant. This is due to the acceleration due to gravity. See, this theta naught is I am going to fix. Okay. If I fix, I can fix it here 30 degree. I can fix it there 45 or 90 degree or 80 degree like that. So I can alter the angle of projectile object. So this angle is going to determine the maximum range of a object, projectile object. So in what condition this equation gets the maximum value? Let's see here, sine 2 theta not equal to 1. When the sine 2 theta attains 1, then this becomes 1, then r equal to v naught square by g. That is the maximum possibility to get the range. Okay. So when what condition it becomes 1? So 2 theta equal to 90 degree. If the sine is 90 degree, then it becomes 1. Instead of 90 degree, where it is 2 theta naught is there. So the 2 theta naught becomes 90. So theta naught equal 90 divided by 2, theta naught equal 45 degree. At an angle of 45 degree, this equation attains the maximum range. Okay. So I have one more doubt. If I change the angle, what will happen? If I change the angle below 45, or I can increase above 45 degree. So what will happen? So that's my question, interesting question. So let's see, let's assume that the theta naught equal to 45 degree plus or minus 5 degree. I can increase 5 degree or I can decrease 5 degree. In both conditions, what will be the range of the projectile object? Let's see, sine 2 instead of 45, I put 40. So sine 80 degree, which gives 0.9848. That's the value for sine 80. I just replaced this 45 instead of 40 here. Here again I am going to replace the 45 50 degree instead of 45. Okay. So 40 and 50. So let's see sine 100. So interestingly, sine 100 also has the same value 0.9848. So whenever if you change equal interval here less than 45 or higher than 45, if you substitute, all gives the same values. That means range r equal to v naught square by g, multiply with this value 0.9848. This 0.9848 is the factor is given for 40 degree also and 50 degree also. That means the range is not going to be different. For both the cases the range will be same. Okay, so that's what that is the interesting idea or interesting phenomenon we received from this particular example. So this equation R is a range of an projectile object. Okay, so that can be easily calculated by substituting this equation is nothing but V naught square times sine 2 theta naught. V naught square times sine 2 theta naught over G. This is the equation to find out the range of the projectile motion